we're asked to divide. And we're dividing 6 plus 3i by 7 minus 5i. And in particular, when I divide this, I want to get another complex number. So I want to get something, some real number plus some imaginary number. So some multiple of I. So let's think about how we can do this. Well, division is the same thing. We could rewrite this as 6 plus 3i over 7 minus 5i. These are clearly equivalent. Dividing by something is the same thing as a rational expression where that something is in the denominator right over here. And so how do we simplify this? Well, we have a tool in our toolkit that can make sure that we don't have an imaginary or a complex number in the denominator. And that's the complex conjugate. If we multiply both the numerator and the denominator of this expression by the complex conjugate of the denominator, then we will get rid of, or we will have a real number in the denominator. So let's do that. So let's multiply the numerator and the denominator by the conjugate of this. So 7 plus 5i. 7 plus 5i is the complex conjugate of 7 minus 5i. So we're going to multiply it by 7 plus 5i over 7 plus 5i. And anything divided by itself is going to be 1, assuming that you're not dealing with zeros. 0 over 0 is undefined. But 7 plus 5i over 7 plus 5i is 1, so we're not changing the value of this. But what this does is it allows us to get rid of the imaginary part in the denominator. So let's multiply this out. Our numerator, we just have to multiply every part of this complex number times every part of this complex number. You can think of it as FOIL if you like. We're really just doing the distributive property twice. We have 6 times 6 6 times 7, which is 42. And then we have 6 times 5i, 6 times 5i, which is 30i, plus 30i. And then we have 3i times 7. So that's plus 21i. Plus 21i. And then finally we have 3i times 5i. 3 times 5 is 15, but we have I times I, or I squared, which is negative 1. So it would be 15 times negative 1, or minus 15. So that's our numerator. And then our denominator is going to be, well, we have a plus b times a minus b. You can think of it that way. Or you could just do what we just did up here. Actually, let's just do what we did up here so you don't have to remember that difference of squares pattern and all of that. 7 times 7 is 49. Let's think of it in a FOIL way, if that is helpful for you. So first, we did the 7 times the 7. Then we can do the outer terms. 7 times 5i is plus 35i. Then we can do the inner terms. Negative 5i times 7 is minus 35i. These two are going to cancel out. And then negative 5i times 5i is negative 25i squared. Negative 25i squared is the same thing as negative 25 times negative 1. So that is plus 25. Now let's simplify them. These guys down here cancel out. Our denominator simplifies to 49 plus 25 is 74. And our numerator, we can add the real parts. So we have a 42 and a negative 15. So let's see, 42 minus 5 would be 37, minus another 10 would be 27. So that is 27. And then we're going to add our 30i plus the 21i. So 30 plus 21, 30 of something plus 21 of that same something is going to be 51 of that something. In this case, that something is the imaginary unit. It is I. Let me do that in magenta. Well, I guess that's orange. So this is plus 51i. And I want to write it in the form of a plus bi, the traditional complex number form. So this right over here is the same thing. It's the same thing as 27 over 74. 27 over 74 plus 51 over 74 plus 51 over 74 plus 51 over 74 times I. And we are done. I want to write that I in that same orange color. And we are done. We have a real part and we have an imaginary part. And if this last step just confuses you a little bit, just remember, this is the same thing, if it's helpful for you. We're essentially multiplying both of these terms times 1 over 74. We're dividing both of these terms by 74. We're distributing the 1 over 74 times both of these, I guess is one way to think about it. And that's how we got this thing over here. But we have a nice real part and a nice imaginary part.